Hello, BR549 here, and I've been following Ruslan replication on overunity.com and for a while, and working on my own replication, and decided to stop on that and back up a little bit and try to understand a little bit more about coils and RF. So I've been working through some experiments, and this is one that I found interesting. This is my circuit right here that I'm currently working with, and what I have is a 6-inch piece of ferrite rod, 1/2 inch in diameter, has infinite resistance, and on that rod I've put 28 feet of number 24 gauge wire wrapped clockwise, and which is my L1, and then my L2 is 42 inches of number 18 gauge wire, half of it wrapped counterclockwise, the other half wrapped clockwise. And my L2 coil weighs or has the same mass as my L1 coil, and my L2 coil is also a even multiple of my L1 coil. Okay. I have current probe here, and I'm using a output, just a single output off of my frequency generator, which is 724 kilohertz. Use these LEDs for a load. I have 4 LEDs, 2 one direction, the other 2 the other direction. Monitoring my output, I have output voltage, scope lead, input voltage, scope lead, and I'm not using either grounds on that. I have a earth ground going into my circuit here, and that's the only ground I'm using on the circuit, although my commons for my oscilloscope and my function generator are tied together so I can synchronize my output. This is my scope, which all channels are set to RMS. This is my current. Blue is my current. Green is my output voltage, and yellow is my input voltage. Now my current probe is not calibrated. All I'm looking for is the difference between my input and my output. And since it's RMS, I can multiply my voltage times my current and get a straight calculation for power. So currently we are on the input with the current probe, and get a pencil here. Our current is output is 84, we'll call it 85, or on, not output, I'm sorry, this is the input. My current reading on my input is 85. I'm going to write that down. 85 times my input voltage is 7.40, 7.4. Now I'm going to move my current probe over to my output here. See that? Okay. And my output current is 274. I'm going to write that down. 274 times my voltage, which is 2.82. 2.82. Okay. So to do the calculations, got output is 274 times 2.82 equals 772.68. 772.7 we'll call it. And my input is 85 times 7.4. It's 85 times 7.4, which equals 629. 629. And my COP would be my output of 772.7 divided by my input power, which is 629. So let's do that. 772.7 divided by 629 equals COP of 1.228. So that would be 1.23, we'll call it. We'll round it up. Okay. So my COP is 1.23. Now, one thing I did notice is that the ground condition of your ground makes a major difference. I can measure the resistance between my two grounds, and this ground goes out to a 80-pound, both of these actually go out to 80-pound plates or grates that are buried 3 feet deep, and the plates are 10 meters apart. So I actually have two grounds. I'm only using one, but I can measure the condition of my grounds by measuring the resistance between the two grounds, and the less resistance, the better COP output that I get. So again, here's the circuit that I'm using, and I am definitely open for any input. Thank you for watching. Have a great day.